All right, we're diving into something pretty mind-bending today, a concept called dynamic info fields. This isn't just another small tweak to AI, it's a completely different blueprint for how it could think.
So, this really gets to the heart of it. The entire reason we're digging into this is to tackle this one big question that someone posed about this new hypothesis. Is a model like this even possible? Let's find out.
You might be asking, why are we even talking about this? And that's a fair question. The thing is, for all the amazing stuff today's AI can do, we're starting to see its limits. We're hitting a kind of ceiling. And that's precisely the moment when you need to start thinking outside the box, way outside the box. Okay, so right now the entire AI landscape is pretty much dominated by one heavyweight champion, the transformer. Seriously, it's the architecture behind basically every big AI model you interact with. It's an absolute beast, but it's also got a massive appetite. And that's where the problems start to creep in. See, a transformer processes information, well, kind of like we read a sentence, but without the intuition. It goes one piece at a time, sequentially. This makes it super energy intensive. It can get confused if you just change the word order, which is not great. And the biggest issue? It doesn't scale well, at all. The more data you feed it, the work it has to do just explodes. We're talking exponentially. That's a real bottleneck. And this is where dynamic info fields comes in and flips the whole script. It's a completely different way of thinking. It poses this really fascinating question. What if an AI didn't have to read in a straight line? What if it could just perceive everything all at once, like a complete picture, a field of information? Just look at this comparison. It puts the difference in stark relief. On one hand, you have the transformer, chugging along, sequentially, one token after another. On the other, this idea of a holistic field, where meaning just emerges. But the real kicker is that bottom line, O of n squared versus O of n. That's not just a small improvement. That's a fundamental shift from this gets exponentially harder to this scales predictably. It's a massive, massive deal for efficiency. So here's a good way to picture it. A transformer is like someone reading a book, but they can only see one word at a time. To understand a word on page 50, it has to painstakingly remember every single word that came before it. It's this long, fragile chain of context.
Now, the info field approach, totally different. It's like looking at a photograph. You don't process the top left pixel, then the one next to it, and so on. No way. You just see it. You get the whole picture, the entire scene in an instant. The meaning isn't in any single pixel. It's in how they all relate to each other, all at once.
Okay, so this all sounds great in theory, but what's actually under the hood? How does an info field work? Well, the hypothesis boils it down to three fundamental building blocks. Think of them as the dimensions that define this entire information space. The first one is called color. And I know what you're thinking, but let's get this out of the way. We're not talking red, green, or blue. Not at all. In this context, color is the abstract identity of something. It's the pure essence, the whatness of a piece of information. It's like the unique fingerprint of a concept. All right, next up is frequency. And just like with color, we're not talking about sound waves here. This is all about behavior. It defines how a piece of info interacts with everything else in the field. Does it attract other ideas? Does it push them away? Does it change them? It's the how of the interaction. And the third and final piece of the puzzle is pitch. This one's really cool. It basically sets the level of abstraction, kind of like a conceptual zoom lens. So, are we talking about something super concrete and detailed, like the specific texture of a banana peel? Or are we zoomed way out, talking about the abstract idea of fruit? Pitch is what lets the model see the forest and the trees at the same time. So you take these three ingredients, the identity, the behavior, and the abstraction level, and you put them together. What you get are these info waves. And here's the magic. Meaning isn't something you force into the system. It literally emerges from the way all these waves ripple and interact with each other, creating patterns and eventually settling into something stable and coherent. Okay, but a field of endlessly interacting waves sounds, well, a bit chaotic, right? Like it could just be noise. And that's a valid concern. To solve that, the hypothesis introduces a few extra tools to help organize the field and give it some much-needed structure. This quote from the source document really hits the nail on the head. Let's just let it sink in for a second. Meaning emerges from the interaction of info waves within a continuous field space. In other words, you're not building a brick wall of logic, you're creating a weather system, and the meaning is the pattern that forms naturally within it.
It's emergent, not engineered.
So how do you tame the chaos? The theory proposes some really clever constructs. You've got attractor-shells, which are basically like semantic gravity wells. They pull similar concepts together and hold them in stable orbits. Then you have steering clusters, which act like rudders on a ship, letting you guide the flow of information. And finally, time modulation is like a conductor's baton, controlling the rhythm and letting the whole field evolve in a coherent way.
All right, so we've laid out this beautiful, elegant theory. It sounds incredible, but now it's time for a reality check. Let's separate the potential from the practicality, because there's a big gap between a great idea and a working model.
And this right here, this chart, shows the single biggest promise of the whole idea. On the left, you've got transformers. That means if you double the amount of text, you quadruple the processing power needed. It gets out of control, fast. On the right, you have the promise of info fields. Double the text, you just double the work. The potential savings in processing and energy are just staggering. It's night and day.
So let's just recap the good stuff, the potential home runs here. You're looking at insane parallelization thanks to that scaling. You're looking at a huge drop in energy use. You're getting a system that's less fragile, that doesn't freak out if you rephrase a sentence. And you get this beautiful, natural structure that grows on its own. It's a pretty compelling list.
But, and you knew there was a but coming, this is still very much a hypothesis. There are some huge flashing question marks. What are the actual mathematical equations that govern these interactions? How exactly do you get the field to stabilize into something that isn't just random noise? And maybe the biggest question of all, how on earth do you train something like this? These are not small problems.
Which brings us full circle, right back to that question we started with. We've seen the dream and we've seen the hurdles. So what's the verdict? Can we actually get from this fascinating concept to a real working system?
Well, the good news is there's a clear roadmap to find out. Right now, we're at square one, the idea phase. The very next step would be to build a tiny toy model, something simple, maybe just a handful of dimensions, to just prove the core physics of it works. If that pans out, then you can start the real work, benchmarking it against the heavyweights.
So let's answer it. Could this model be possible? The most honest answer, based on the deep dive into this hypothesis, is a resounding maybe. And that's a good thing. It's not proven, not by a long shot, but the idea holds together. The structure makes sense. It's coherent enough that it absolutely 100% warrants a closer look. It's earned the right to be explored.
And that's really where we're left. We've seen the incredible potential and the very real challenges, and it all boils down to this. Are we looking at the next great leap forward, the actual future of how we build intelligent systems? Or is this one of those brilliant, beautiful ideas that's just a little bit ahead of its time, waiting for the right breakthrough to make it a reality?